All right, but this is the last section. Yay. So last part. And honestly, this is not that hard, okay, to be honest with you. If you don't have a calculator in front of you, though, you need a calculator. You do. Doesn't matter. Personally, I think the graphing ones are easier to deal with, but it doesn't mean you can't use the other ones. That's just my personal preference, whatever you're more comfortable with. All right, so we've dealt with radicals, we've dealt with fractions for exponents and how to switch them back and forth between the two forms. Sure, that's fine. So we've worked with all of that. Now we're going to actually solve. We're going to have equations, we're going to have equal signs, you're going to get an answers of x equals blank. Okay, we're going to actually use all of our knowledge to go ahead and solve things. Also, one important part we've dealt with in the past is they will have some of them extraneous solutions. Do you remember what that means?
Yeah.
What's that mean?
You have to look at the radical, right? Or the restrictions.
You're thinking back to the restrictions? Yeah, it's answers that don't work though, right? Extraneous means it's an extra answer that showed up that really actually doesn't work. So we will have those to deal with in this section. Okay, so part one, radical equations. An equation with a variable inside a radical is called a radical equation. And that's the first type we're going to look at, is how do we deal with them when there's radicals in our equations. So if the index is 2, the equation is called a blank equation. What's it mean if the index is a 2? It's a square root. It's a square root equation. Like down here is an example of it. If there's no index, we know that unspoken number in there is a 2. So that's a square root equation. So that's the type of thing we're going to look at solving. Okay, so how to solve a radical equation. Blank the radical on one side of the equation. I was looking for a specific word, but yes, you're on the right track. I was looking for isolate. Right, we're going to isolate it on one side by itself, right? Move everything else away from it. To eliminate the radical, do its blank. Do its what? Its opposite. What does it mean to do the opposite of a square root? You would square it, yeah. You will raise each side of the equation to an, exponent, that's the word I was looking for there, to an exponent that is equal to the index. So if it was a square root, you square it. If it's a cubed root, you will cube it. If it's a fourth root, fourth it, raise it to the fourth, right? Whatever that index is. Yeah. Yes. Yep. So after you do that, you are eliminating the radicals, what you're doing. Then you're just going to solve for x, whatever that means, whatever you got going on in there. And then you will check your answers by substituting it, plugging it in, substituting it into the original equation. So or plugging it back into whatever word you want to lose there. So in other words, whatever you get for x, plug it in for your x's, make sure it actually works. You should never have a wrong answer. There's nothing worse than when I'm grading tests and you give me a wrong answer and you circled it like it was the greatest answer there ever was. If you'd have checked it, you'd have known it was wrong, right? So again, you should never miss these. All right, solve each radical equation. So is your radical isolated? Yep, it's totally by itself. So what is the index here? Say 2. So how do you undo a square root? You square it. And if I square this side, I got to square the other side. So what happens to my square root and my square on the left side? Yeah, these are going to cancel each other out. So I just have 3x minus 2. It makes that whole radical part go away. And what's 4 squared? And then just solve. Yeah. Yep, so we'll add 2. So 3x equals 18. Divide by 3. X equals 6. Pretty close. I mean, they get a scotch harder, but Yeah, like I told you guys, that last section, that was the hardest thing in this chapter. This is easier than what we just did. And some of you, if you thought the last part was easy, then that's fantastic. That makes me happy. All right. Now, whoa, whoa, whoa. You all just flipped your page. You didn't check it. I didn't tell you it was right. I just finished solving. But could it be extraneous? Could it be extraneous? It could be. You need to check it, make sure it's not extraneous. Now, as far as checking goes, back to the original problem before I wrote all over it, you can just type this in your calculator. Okay? So if you do it in the graphing ones, it opens up the radical that like kind of continues on with you. So for me, it's easier because I can see it. So if you type in the square root, and you're going to do 3 times 6, and then minus 2, and it says it's 4. And it's 4. Now, if you're doing this in your scientific one, which is fine, it still works. Just be careful. It will open a parenthesis when you type in your radical sign. So just make sure you close the parenthesis and then hit equals. If you have an equation that has more stuff in it later on, you'd have to make sure you close it. For example, if you would have had, something like that was the original, like there was extra stuff. So when you opened up this in your calculator, it opens a parenthesis. You would type in your 3, that's my multiply sign, that's terrible. 3 times 6 minus 2, you'd have to close that to indicate that's the end of what's under there, and then plus 5 and hit equals and see if it worked. Does that make sense? Like you have to close off whatever's in your radical if you have more stuff. If you don't have more stuff, then it's fine. All right. So like this one has more stuff, but it happens to be in front, so it's not as bad. So what do I have to do first on number 2? Isolate it. So what needs to be moved? To 3. I'm just going to subtract from 3 to the other side. And then what? Good. This is a square root, so we will square both sides to undo it. The radical and the square are going to cancel each other out and just give me 5x minus 6. 4 squared, 16. That's great. And then we just solve. So add 6. So that's going to give me 22. Divide by 5. Is it okay that it's a fraction? Yeah, just 22/5. Where do you check it? Plug it in where? Where in my line of work? The original. I just want to make sure we're clear. You'll have to go back to the original before you wrote on it. Yep, type it in exactly the way you see it. So 3 plus, then your square root. You have 5 times 22/5 minus 6, hit equals, and I got a 7. Did it work? Isn't that great? Right? And you're like, oh, a normal answer. Is there anyone questioning how to type stuff in to check? If you're going to struggle anywhere, it's going to be on your calculator today. Oh. Let's go ahead and skip 3. Let's look at 4. Again, I'm trying to get through all of this today, so I may hop and skip a couple problems. So number 4, what do I do first on that one? Subtract the 6, yeah. Again, if you're like, do I get rid of the 3 or the 6? Think about if I just had 3x plus 6 equals 24. What would you do first there? You'd move the 6, right? Same idea over here. This is like a big giant X. You're going to subtract the 6, then we'll divide by the 3 on both sides of the equation. That way this is gone. Okay. Good. Then you're going to divide by the 3. Yeah, this is, right, yep, we have different things going on here.
Wait, so, repeat what you said. I don't know what you
That 3 is being multiplied by the radical, and we were trying to get the radical all by itself. So anything outside of it, I need gone. All right, again, my index is a unspoken little 2 there. So not until it's completely by itself, then we will go ahead and square both sides. So we get 2x plus 4, because the radical and the square cancel out. 6 squared, 36. And we solve like normal. Subtract 4. 2x equals 32. Divide by 2, and x equals 16. And then check it. And again, when you're checking, back to the original. So you're going to have to start with the 3. Now, you don't have to hit a multiplication sign after the 3. Your calculator recognizes if you just type it in next to each other. And then 2 times 16 plus 4. Now, if you are on the scientific calculator, you will need to close your parenthesis after the 4 before you hit plus 6. If you're on the graphing, you're going to have to arrow over to get it out of the radical, so it's no longer underneath there, and then hit the plus 6. Does that make sense? Are we okay? I'm going to keep going if you don't yell at me. All right, number 5, the cubed root of 5x plus 2 equals negative 2. Yes. Yes. Yeah, if that's the only answer you got, then and it doesn't work, yeah, no solution. So for this one, is my radical by itself? Yeah, it is. Because this isn't a 3 being multiplied, that little 3 is my index. So how do I get rid of that cubed root then? Yeah, so now I'm going to cube both sides. Okay, so it's whatever your index number is what you raise both sides to. So that way my cubed root and my cube, they cancel out, and I have 5x plus 2. And then negative 2 cubed is negative 8. Now, in this case, it didn't make a difference, but would it make a difference if this had been an even exponent? Yeah, that has to be in parentheses. Notice every time I've been putting my numbers in parentheses before I square it, cube it, whatever, type those parentheses in as well. An odd one doesn't make a difference, but the even ones, it really does. All right, we're going to go ahead and solve from there. So I'll subtract 2. 5x equals negative 10. Divide by 5. And x equals negative 2. Took over. It didn't work. Why not? You said it does? Oh, try typing it in again. Try it again. On that one, you're going to have to hit 3 and then your second caret. Yep, to do your index. Okay. Oh, wait a minute. No, hold on. I'm glad I just looked at yours. On the scientific one, it looks like this. It's got 3 and then it does this with a little x on it for cubed root on the scientific ones. It didn't open a parenthesis for you. Otherwise, what your calculator's doing is only doing the cubed root of 5 and then multiplying it by your next number. Like, it's not knowing all of that's supposed to be under there. So this is what you should have first. Type in your 5 times negative 2 plus 2, close your parenthesis, and then see, does it work? Okay. No, I'm glad that you brought that up. It's funny, it opens it up for the square root, but it doesn't for the cube. Okay. Yeah. So just make sure you watch for that. Got to make sure every time you have a radical, there should be a parenthesis open. All right, so I'm going to bypass 6. Let's go to 7. I skipped 6, jump into 7. So no homework tonight. Are you going to be here tomorrow? Okay, so you'll be able to work on everything tomorrow. See you later. All right, number 7, what do I do first? Add the 5. There you go. Don't ever divide first unless that's the only number you have to move, right? We always add or subtract and move them out of the way first. So 2 times the cubed root of 8x equals 8. Then what? Not yet. Divide by the 2. We can't cube both sides until it is completely by itself. Right. Now the radical is totally by itself. Now I can cube both sides. So we get 8x equals 4 cubed. It's 64. Divide by 8. X equals 8. How are we feeling so far today? Okay. Yeah, it's not too bad. Honestly, the hardest part of today is your calculator. You may have. Who was your teacher for intermediate? Yeah, she may have touched on some of the stuff. Yeah, she may have touched on some of it. Did you guys check it? Does it work out okay? Okay. All right. Are we good if it's a fourth root, you just raise it to the fourth? Yeah. All right, I'm going to bypass that if you guys are cool. Let's look at number 10. Sorry, I'm trying to get through a whole lot today. Makes me nervous because we have shortened periods to try to get through it all. So number 10, why is this one different that I would stop here? Put a variable on the other side. I've not had that before. Okay, same rules though, same process. Is your radical by itself? Okay, so then what's my index? So how do I get rid of it? You square it. So that radical is going to cancel out, and I have 3x minus 2 equals x squared. Yes. Anytime we're solving and there's an x squared, we set it equal to 0 and we factor. Factor. So we always want our x squared to be positive, so I'm going to move everything over there. So that becomes x squared minus 3x plus 2. Yeah, if you're more comfortable with that on the other side, that's fine. Okay, but when I want my squared term to be positive, so I moved both of these to the other side. And then we can factor this. So I have x and x. What are my signs? Both negative. Options for C? 2 and 1. And 2 and 1 make 3? Yeah, okay. So then what does x equal? 2 and 1? Do they work? So what this means when you're checking, I want to make sure we're clear on how to check something like this. Again, back to the original. So when you're first checking, like I'm going to check just the 2 to begin with. So if I plug the 2 in here, that means this equation should equal 2. Does that make sense? Yes, 1 at a time. And then when I plug in a 1 for here, that means I'm looking for a 1 to be on that side. Does that make sense? I have to check each one at its own. I don't do them both at the same time. Did someone check both of those? Do they work? You check the first one? Did you check the second one? Yeah. 3 times 1 is 3, minus 2 is 1, the square root of 1 is 1. Yeah, that works. Yeah. Okay, but again, if you have the x squared, set it equal to 0, factor, and solve. Let's look at 11, because this one opens up a whole nother ball of wax. Okay, so on 11, you're right, I moved the 3 first. I'm going to have to add it to the other side. So, if you say 3x, that implies that it's being multiplied. X plus 3. Yep, because you're adding it to the other side, so it's x plus 3. So how do I get rid of my radical now? I have to square it. So we get 11x plus 3. No. She's on it today. Yeah, what's it mean to square something? It means you multiply it by itself. Yep, we're going to have to distribute that. Now, I know you guys are kind of in the mindset of if there's an exponent on the outside, I distribute that to everything inside, right? But those two things are being held together with a plus sign. I can't distribute to that. Everything that you've distributed into, like on the previous section, there was never been a plus or minus sign in between there. They've all just been terms being multiplied. So we do need to multiply this together. So we get x squared plus 3x plus 3x plus 9. Yeah, the biggest mistake people will make is they won't multiply that out together. So I have some like terms. So I have x squared plus 6x plus 9. Solve like normal, or do I have to set it equal to 0? Equal to 0. And my x squared is positive over here, so I'm just going to move everything else to that side. So x squared, I have to subtract 11. So 6 minus 11 is negative 5x. Subtract the 3. 9 minus 3 is a positive 6. That's right. That combination, you got to really stop and think. What are my signs? That should help. Put those in first. So is it 1 and 6 or 2 and 3? It's 2 and 3. That way we get that negative 5 in the middle. So x equals 2 and 3. And then where do I check them? All the way back at the top, and I have to check one at a time. Is that working? Somebody check 2? Somebody check 3? Mm-hmm. Yep, you can end up with both of them work. You can end up with both of them don't. Or you can end up one does and one doesn't. Just never know. Hmm? All right, so that was all I was going to teach you today. But I'm not here tomorrow, so I'm going to teach you tomorrow's part as well. Okay? So tomorrow we were going to look at when you have rational exponents. So you have a fraction for an exponent. Now, could I flip that back into radical form? You could, okay? And that is one option. I will tell you it is not the easiest option, okay? So I'm going to teach you the easier way. So first you will isolate the rational exponents expression. So get it by itself. So you're getting the parenthesis with exponents by itself. Move away anything that's not in that parenthesis. Then you will raise each side of the equation to the blank of the exponent. Nice. To the reciprocal. What's the reciprocal of 4/3? 3/4. Don't change the sign, though. Don't change the sign. Yeah, you just literally flip it over. If the denominator, this is like circle this, star this. This is like one of those weird random rules that we always have to remember. There's always something, right? Not that it's hard, you just got to remember it. If the denominator of the new fraction is even, what's the denominator mean? Right, it's the bottom one. What does that number mean? If you're flipping it to the other form, what is that? If I would flip this back to radical form, it's the root, right? Like if I would write this would be the cubed root of x plus 3 to the 4th, right? The denominator is my root. And what did we talk about if it's an even root? Your answers would have to be plus minus. Yeah. Because before, anytime you took the square root of something, your answer was plus minus, right? So the same goes if it's a 4th root, 6th root, 8th root, 10th root. Any even root, your answer is plus minus. Yay! So again, weird random rule, not that hard, but you got to remember to do it. Same thing with square roots. And then again, you can check to make sure they work. All right, let's jump in. So number 1, I need to isolate the parentheses part that has an exponent to it. Divide by 4. Are you allowed to distribute that 4 in there? No, because that exponent's kind of holding it prisoner. It's not letting anybody in. So divide it by 4. So x minus 3 to the 2/3. 64 divided by 4 is 16. I'm not distributing. Reciprocal. So you're going to raise both sides. What's the reciprocal of 2/3? 3/2. Okay, the question of why? So let's stop and think. Nobody write anything down. Look up here for a minute. An exponent outside here to an exponent would mean you multiply them, right? What's 2/3 times 3/2? It'd be 6/6, which is 1. So in essence, it's gone. Yeah, it's canceled. So, because that's 6/6, which is 1, so really that's x minus 3 to the first, or just x minus 3. It allows that to go away. But if I do it on this side to get rid of it, I have to do it to that side. And lucky for you, you have a calculator to make your life even easier. What's 16 to the 3/2 power? What is it? 24? Do you guys concur?
64.
Yeah, it'd be 64. It would be 64. Because that's the square root of 16, which is 4 to the 3rd power, which is 64. Now, what do you notice about my denominator of my reciprocal? That's even. Which means that 64 is plus minus 64. Well, we're not done yet. Close. Yes. Do you remember doing this before? We did this all the time before. So x equals 3 plus or minus 64. What's 3 plus 64? 3 minus 64. Yeah, again, we've seen that. We've done that process before when we were doing like completing the square and solving some of those square root method ones. If it's odd, you don't have to worry about it. Yep. Reason being, kind of like we did with squares. If I said 5 squared is 25, what's negative 5 squared? Still 25. Both the positive and the negative still gave me the positive 25. Same thing here with a different span of numbers, but like think about with cubes. What's not cubes? 4, like so 4 through evens. So what's 2 to the 4th? 2 times 2 times 2 times 2 is 16. What's negative 2 to the 4th? It's still 16. So any even one is going to always make that answer work out positive. So you have to have plus and minus because you could have either option in there. So can I check these? Yeah. I go back to the original and we check them up here at the beginning. Go ahead and take a minute. Make sure we're okay to check these. And again, you have to check one at a time. But you guys know that once you checked one, it's really easy to check the other one, right? Just by arrowing back into your equation. You can check it really fast that way. Okay, just, again, just try at least one of them. I know both of them work, but I just want you to make sure we can type them in okay. Because you got fractions for exponents and all that good stuff. All right, does anyone need help typing it in? Are we okay? Okay. Got it to work? Taylor, you okay? Jonas? So number 2, what do I have to do first? Add the 12. So 5x to the 1/4 equals 30. Divide by 5. Now this one didn't have a parenthesis, which means that 1/4 is only attached to that x. That's it. So whatever that fractional exponent is attached to, that's the part you get by itself. And once I get to here, I will raise them both to the reciprocal of this, right? What's the reciprocal of 1/4? 4. Or 4/1 if you really want to do it that way. So that way those cancel. I have just x. And then what's 6 to the 4th? 1,000 what? Did I need a plus or minus here?
Yes.
What's the denominator? The denominator is odd. So no plus minus. I know, it's just one of the, again, you just got to remember that stupid rule, right? Get that stuck in your head. It's the denominator even plus minus. Probably, so you don't accidentally think that that was even. Yeah, both numbers are odd, so you're good, right? All right, so what do I move first? Don't distribute. Well, I'm going to count it wrong, so don't do that. I get why that's your instinct, but that exponent makes it where you can't. So we added the 4, then we what? Good, divide by the 3. So x plus 5 to the 3/5 equals, is that 27? I don't multiply by the reciprocal. Okay, 5/3. My denominator is odd, so no plus minus. So x plus 5 equals 243. Is that right? All right, and then subtract the 5. Not overly difficult, just remembering that rule. And can you check it to make sure you did it right? Yeah, you can. You tell me. You think we're going to have some extraneous ones here coming up? Knowing me, yeah, they're going to come up. All right, let me see. Oh, yeah, look at number 4. I have a cubed root of something to the 5th power. Do you know how to rewrite that? We know how to write this. So this is 2 times x plus 2 to what power? 5/3. So yeah, so if you have something written like that with the radical and the root and the exponent and all that craziness going on in there, you can just rewrite that, flip it into your other form. That is totally fine. It makes that problem a lot easier. So what would be my next step? Yeah, subtract the 7. (71 minus 7), so 64. Divide by the 2. Equals 32. I won't count you wrong as long as you do it right. But I fear some people doing too many steps at once making mistakes. So just be cautious. Okay. All right. Once it's finally by itself, right? This exponent goes on this entire parenthesis, so that whole thing needs by itself. Then we raise both sides to what power? 3/5. So the x plus 2 equals, is that 8?
Yeah.
Is it plus minus? No, because that's odd. Good. Subtract the 2. X equals 6. And check your answers. Make sure they work. All right. How are we feeling about all this solving so far? You like it? It's not too bad, right? Just got to remember that crazy odd denominator or even denominator rule. What? What? Huh? All right, skipping then to part 3. Woohoo, last part. On part 3 is just where the ones that have extraneous will show up. Okay, same idea. I just want you to kind of see some that actually have extraneous to them. All right, so it is necessary to check every solution because some of them do not satisfy it. If they don't check out, they are called extraneous solutions. We've seen that word numerous times. In other words, all it means is you checked your work and it didn't equal what it was supposed to. It just means it's extraneous. Okay, before you mark one being extraneous, though, you may want to check your work a couple times, make sure you typed it in right. Okay. So, this is back to the very first thing I taught you. Is your radical by itself? Yeah. What's your index? 2. So we will go ahead and square both sides. So I get 2x plus 1. What is negative 3 squared? 9. Make sure when you're typing that in your calculator that you actually remember the parentheses because that makes a big difference. And then solve like normal. Subtract 1. So 2x equals 8. X equals 4. Go ahead and check that. Again, we check back up here. Back to the original. What do you get? I get 3. Is that the same as negative 3? This is no solution. Yeah, that's fine. If you want to be even lazier, you can do a 0 slash through it. That's fine. It means no solution. Okay, so just be careful. It did come out as 3, but that's not the same as negative 3. Okay? We good? Yes? Ooh, that's a pretty one. So is the part that needs to be by itself? Yeah, because the part that crazy exponent is on the parenthesis, and that's totally by itself. So how do I get rid of the 1/2 right there? I square it, or 2/1, just so I can check that rule. Because my denominator is odd, so I don't have to worry about the plus minus. So I'm going to get x plus 7 equals, what does that mean? Good, that means I have x minus 5 and x minus 5. Then we're going to have to distribute that. So we get x squared minus 5x minus 5x plus 25. Distributing all of that together. Some like terms in the middle there. So x squared minus 10x plus 25. Good. This one has to be set to 0 because I have an x squared term. It's positive where it sits, so I'm going to move everything to that side. So I'm going to subtract my x. Give me negative 11x. Subtract the 7, which gives me a positive 18. All right, and then we have to factor. What are your signs? And what's my numbers? 2 and 9. Yep, hold that thought. So x equals 2 and 9. All right, so when we are checking, again, I got to check them both separately, okay? So when I check, let's say I check the 2 first. I'm going to type this in, right? I'm going to put a 2 right here in my parenthesis. I'm going to type that in. Maybe do a little mental math on your own part. What's 2 minus 5? Negative 3. So when I hit equals, it should equal negative 3 then, right? Because I had an x over here, so I needed to see what my calculator is going to spit out for me. It's going to be whatever that side is. So check the 2. Okay, did anybody check the 2? You got 3. Right. So when you plugged in a 2 on this side and got 3, and this says negative 3. That's extraneous. And the 9 worked? Okay. So again, when you're checking the 9, just to make sure we're clear, that means this is a 9 here, and a 9 over here. That would give me 4. So when I type it in, hit equals, it should be a 4. You might have to do a little mental math over there. Okay. Questions there? You guys are doing awesome.
So when you get your like x squared plus 11x plus 18,
Mm-hmm.
and you're subtracting 11.
I'm not sure I understand your question.
Like you said that everything in the
Like,
x squared.
yes, I moved it where my x squared is positive, so I subtracted this over here,
So what? Okay.
and I subtracted this one over here. Put my like terms together, and then I like them in standard form, so I can factor. All right, that's the same idea. Let's bypass that one for a minute. Let's look at number 4. What do you do there? You what? Subtract the 6? Yeah, I jumped. Sorry. I'm jumping problems on you. So we get the square root of x equals x minus 6. I have to square it. So I get x equals, what does that mean? Yeah, that means I have two of them that I have to multiply together. So x squared minus 6x minus 6x plus 36. I have like terms. So x squared minus 12x plus 36. Solve like normal or set equal to 0? Equal to 0. So again, I'm going to move it to where my x squared is positive. So I have to subtract x over here. So x squared would be minus 13x plus 36. And then we have to factor. What are my signs? Both negative. 9 and 4, good. So x equals 9 and 4. So when I go to check this back in the original, if I plug in a 9, again, that goes in both spots. That's a 9, which means it should equal 9. 9 works? 4 doesn't? Yeah, that would equal 8. Okay, so that means 4 is extraneous. How are we feeling? I know I've went through a ton today.
I'm going to forget how to do half of it.
All right, let's look at this one, because that looks weird. Now, I have two things that have fractions for exponents. Yeah, because what's happening here is you need to isolate both of them. Can I isolate them on opposite sides? Yeah. Now, when you move them, when I move this one over here, does what's in parentheses change? It does not. It's like if I had negative x to the 1/2 and I moved that, it would change it to a plus on the other side. But it doesn't mean the x changed, just the number in front of it did. So I'm like adding this whole piece over here. So it becomes 2x minus 5 to the 1/2. The part that changed was the sign in front of it changed. What's in the parentheses, I want to make sure we're clear. The in the parentheses, that sign does not change when it moves. It's because that entire piece is one piece moving to the other side. So then I have to raise both of these to what power? The second power. So when I raise them both to the second, or the 2/1, do I need a plus minus? No, this is odd. Question? Am I doing them both? Yeah. Hold that thought. It's coming. It's coming. I promise you it's coming. She's looking ahead. It's coming. You're just thinking into the future? It's coming. Hold your thought. It's coming. I promise you it's coming. So what happens to the exponents on both of these? I cancel. So I just have 5x plus 7 equals 2x minus 5. Yeah, I can just go ahead and solve like normal. So I'll subtract 2x. X equals negative 4. Now when you check, you can type that whole thing in the calculator. You just got to be careful. So yeah, when you put this whole thing in the original and you hit equals, it should tell you 0. All that for a 0. So go ahead and check it. If you plug it in there, does it give you 0? Does it work? Did you check? She didn't check it. She was just sitting there staring at me. What do you guys think?
I got a domain error.
A domain error?
I don't know what I did. I give up.
Well, let's talk about it. Okay, let's talk about it. See what happened. 5 times negative 4 is negative 20 plus 7. That'd be negative 13 to the 1/2. So your calculator is smart, but is not overly smart, right? Your calculator doesn't handle imaginary well, because this means the square root of -13. But hold on, what does this one give me? What's 2 times -4 minus 5? This is also -13 to the 1/2. If I take this, which would be what, I radical 13 minus I radical 13, do I get 0? So if you're typing it in and your calculator says domain error, you need to look at that as in it might be imaginary. So then just kind of do one piece at a time and see if it works. Real quick, I know I'm about out of time. The one that she was asking me on, something like this, they're already isolated. When you go to raise these, I have to raise each side to the same number. Nope. This one reciprocal is 2, this reciprocal is 4. Use the bigger one. It's going to be 4. In the problems I give you, it's going to be use the bigger one. If you are looking in the future in another class, you will have to use the common factor. It is a common factor. So real quick, guys, if I did this one, half of 4 is 2. That one's going to cancel. You're going to have to multiply this out and then solve from there. Does that make sense? Okay.